University. Today we are going to look at our course, the Managing Information Technology. Remember, we're doing how to manage information technology. This course is about managing informations, managing technology, and in this course today we'll be looking at chapter 2. And chapter 2 basically is about computer systems, and in computer system we'll be looking at the hardware and the software. Okay, without much ado, let's begin. Now, the hardware is a very serious foundation of any computer. The hardware is the building blocks of information technology. If there is no hardware, we will not be talking about the information technology. And this building block of information technology is not only limited to the hardware aspect. It comprises of about 4 segments of this computer system. The first part is the hardware, which we've mentioned. The first part of the information technology, or what enabled information technology in our today's world, is the hardware. The hardware is the very integral part, which we're going to talk about. What consists of the hardware is the physical part of the machines of computing. Now, the second one is the software. The software is the soul of the computer, so to say. So permit us to use that language. It's the blood that flows in the body of a human being. For example, if you are making an analogy of a human being and a computer, it's the soul in more advanced way. It's the soul of the human body, for example. The same way the soul is to the human body is what the software is to the computer. So the software, there will be no computer operations without the software. The softwares are the languages. You know, we have types of software, the application software, and the support system software, which is the system software. So all of this enable the programs, enables the computers to do whatever is designated to do, the task that it is be designed and developed to do. Then the third aspect of information technology, the things we'll be looking at in information technology that comprise the third segment, is the networks. We'll be looking at the networks, the various networks that enable communications of information technology. Then the last but not the least is the data itself. In the network, we'll be dealing with the network in chapter 3. Okay, in chapter 4, we'll be dealing with the data. The data itself is the core segment of the information technology. So we're going to look at these 4 various segments: the hardware, the software, and the network and data. Now let's begin to look at the very first one, which is the hardware. As we know from the foundational computer science, the hardware is the physical pieces of a computer, the part of the computer you can touch, like your monitor, your keyboard, whatever you can touch in a computer is the hardware. The physical body of a computer is the hardware. Okay, now the software is a set of programs that controls the operations of the computer. The software is like a language, a program, a package that enable the hardware to execute. Okay, without the software, the hardware will not function. Just like without the soul, the human body will be dead, will not function. Okay, so software are like the soul of the body, while the hardware are like the physical body of a human being. Is that okay? Now we move on to the component, the basic components of the computer system. Now, in the components, the computer has an integral entity comprised of 6 broad aspect. Now, one of it is the input component, or the input aspect, or the input device of a computer. The second one is the memory. The memory is another aspect of the computer. And the third one is the output device of a computer, where we display whatever we have done. The input is to put data into the computer, put whatever graphic, video, whatever we need to inject into the computer, put it into the computer, are done by the input devices. The memory is the one that probably helps to save temporarily or to help to process whatever we need to do. And then the output device deals with the display of whatever has been done. And then the fourth aspect is the control unit. The control unit regulates, control, implements whatever that needs to be done. And it is integral part of the central processing unit of the computer, the one you call the CPU. The CPU, remember, of the computer is divided into 2 segments. The CPU comprises of the control unit and the arithmetic and logical unit, right? So the arithmetic and logical units, although is the CPU of the computer, but is divided into two segments. Now the control units and the arithmetic and logical units. So the arithmetic logical units, already two segments of the computer. Arithmetic logical unit one segment, control unit one segment, both of them, and the central processing unit of the computer. So there are two. The central processing unit is divided into two, the control unit and the arithmetic and logical unit. Okay. Now this is intertwined, this control unit intertwined with the memory and the input output device and the file. So all of these comprise the 6 blocks that makes up the external and the big component of the computer. Now we move on to the next one. Now here we have a basic components of computer system. You can see we have the memory, the processor. The processor, we have the Core i7 Intel by Intel company, one of the biggest corporation, microchip corporation in the United States, in the Silicon Valley in the United States, California, USA. Okay, so they're one of the biggest companies that are into producing the memory components of the computer system. Most of the computers, whether they're US computers, they're non-US computers, they use the Intel processors for their capacitations and for their computational mechanisms. Now let's move on to still on the basic component. Now we take them one after the other. We mentioned 6. We say the input, the output, the memory, the files, the control unit, and the arithmetic and logical unit. Now we start with the first one, the input. The inputs, they are just devices that are used to enter data into the computer. Enter whatever the data you want to get into the computer, the information, whatever you put in the computer. The input devices are used to carry out this functionality. Now we move on to the next one. Okay, without much, we don't need to waste time. Now, before we move to the second one, let's take a look at the input. You know, we have different types of input devices. Okay. When we say input devices, the keyboard is input device, the mouse is an input device. There's so many things we use to input data into the computer. Okay, so let's take a look at the difference between a terminal and a PC first before we progress. Okay, what is a terminal? What is a PC? First, we look at a terminal. A terminal is like a PC, but the difference is that it does not have a processor. It has the input device and the output device. It does not have a processor. That's a terminal. A good example is like the ATM machine or the point of sales terminal, the one you call POS, the one you can use to like do bank transfer and so whatever from an account to an account and so on and so forth. Is that okay? So it's a terminal. It's not a full computer. The ATM is a terminal. It's not a full computer, but they work with a computer because they're connected to a computer system. They can, especially the ATM, do not work alone. They're connected to a processor, whatever processor. Okay, so a terminal comprised of the input, the output, without like a internally built processor, while a PC has the input, the output, and the processor. A PC is a 3-block device. Okay, the input, the processor or the memory, whatever you want to call it, and the output. Now let's take a look at the common input methods to key in data into the computer, to put data into a computer. We mentioned them verbally. One is the keyboard. Keyboard is used to enter maybe the user's inputs entered by user through like a keystroke, like you're typing, you hit it, you type it, like keystrokes, you are keystroking. Okay, you're typing, you're like what we call typing, you're hitting the keyboard and you type it A, B, C, D, 1, 2, 3, whatever you put it, you're keying. So as you're hitting the keyboard, the data is being entered into the computer. So the keyboard is one of the input devices or a method of inputting data into the computer. Now let's take a look at the second one, the mouse. The mouse, stylus, you can call it mouse, stylus, or touchpad. You know, we have touchpad. There's some you don't have to. You have some touchpad like the Mac, the whatever. You know that, right? The touchpad. The touchpad easily can also be used to input data into the computer, right? They are alternative to keystroking. You don't have to keystroke to put an input or a data into a computer when you're using a mouse, a stylus, or a touchpad. The third one is the disk drive or the flash drive. You know, the flash drive, you just put it in your computer, you copy the data or you copy the files to the designated place you want it to be in the computer. You know, the data of the files, they were in the flash drive, the memory drive, whatever drive that you key, you can just copy from there and put it in the computer to do whatever you want to do. Okay, so it's a way of inputting data into the computer. Another way is the magnetic ink character recognition, the one that is used by the bank. What do bank use magnetic ink character recognition to do? The MICR. They use it to process the bank check. You know, the check, the bottom of the check, there are some numbers that are read by this magnetic ink character recognition. So when you bring a fake check, the bank there's a MICR that passes through, scans it, and it tells you whether it's authentic, it's correct, it's okay to go. Then so it's used for inputting data into the computer. Another device that is used for inputting data into the computer is the barcode labeling. The barcode labeling, they scan the barcodes on packages and products that you buy or you want to pay for, and then read the data into the computer immediately. Okay, without keystroking, without any method else other than just scan it through it, and then the data are all imputed into the computer. Another method of inputting data into the computer is the optical character recognition, OCR, optical character recognition. And these ones are used by, you know, like this exam, multiple choice exam, like in Africa, and like in United States, you have SAT exams. In Africa, you have the JAMB. In Nigeria specifically, you have the JAMB, JAMB, Joint Admission Matriculation Board. You know, this type of exams, they use the optical character recognitions to impute those data into the computer. Directly scan the typed, you know, when they are already typed like paper. When you just bring your answer sheet, you know, the answer sheet, the one you are shading, you know, they gave you shade 40 multiple choice exam, and then you know how they mark. They don't mark manually. They just put it in the computer and the computer grades it. They scan it. It scans it into the computer, and the right ones are marked wrong. The right ones are marked right. The wrong ones are marked wrong automatically. So it's called an optical character recognition. It recognizes whether handwritten character, typed character, whatever kind of character, printed character. It's able, whether pencil character, shaded character, it's able to recognize the optical character recognition is able to do this. Okay, so it's another device for inputting data into the computer. Another one is the imaging. Imaging imputes digital form of documents. Digital form of documents. So when we're talking about digital form of document, we're talking about photos, videos, and all of these things. So imaging is a software, and not just a software, a way of imputing this type of digital data into a computer. So we move on to the next one. We go to output devices. An output device is needed to produce the result in a usable format, a format intelligible enough for you to see, for you to understand. Okay, the computer does whatever it has to do based on the language, based on the Java programming, whatever assembly language it uses, whether it's using HTML, whatever language that it has used to run, to execute. After all of that, the computer brings out an intelligible something for you to comprehend. Now the display is the output. Wherever I put it, whether it's on the screen, what you call the monitor is an output. The printer is an output device. So all of this, wherever it brings it out for you to see it, is an output device. Okay, so output devices are needed to produce result in a usable format. Now let's take a look at the common output method. What are the methods you use to show your output from your computer? One is the video display unit. The display output on a screen. Okay, this one shows the output of your data from your computer on a screen. Another one is the disk drive or flash drive. Okay, output written to a disk. You can write something to a disk for a storage, right? Then another output device is the printer. The printer is an output device, right? So output to papers, various type of printers, you know, whether it's a dot matrix printer, whether any kinds of printer, okay, inkjet printer, whether any type of printer is an output device. Now, compute another one output device is a computer output microfilms. That's what we call microfilms. Okay, microfilm generated for archive copies in small space. Okay, so it's an output device. Another output is the voice response unit, the computer, what we call the VRU, the voice response unit, computer generated verbal response messages. Okay, it's an output display unit. Then we're done with 2 out of 6 components. Now we move on to the third one, the memory. The memory. Now, what is the memory? The memory is at the heart of the computer. Just like, we have the brain, which is the processing unit. In human body, we have the brain, right, which is the processing unit. And in this processing unit, the CPU, you have the control unit, and you have the arithmetic and logical unit, right? And then you have the heart. There are 2 huge memory in human body. People don't know the heart is it's a memory. It's a memory. The heart is for wisdom, the brain is for knowledge, right? Same with computer. The computer has the CPU intertwined with the memory. The memory is like the heart, and the CPU, which is divided to control unit and arithmetic and logical units, is the brain in human analogy. Now let's go back to where we are. Now the memory itself. Now what is the memory used for or refers to? It's referred to as the main memory or the primary memory. Memory is a capacity to store, right? So all data flows to and from the memory. Every data in a computer system, whatever you do with the computer system, goes through the memory, okay, flows to it and comes out from it. Is that okay? Now all data flow to and from memory, and they can divide it to cells. The memory are divided to block or cells, because the memory does a lot of things that you cannot imagine. You cannot imagine what the memory does in a computer. You can imagine what the computer do for you. Computers are used for programming, for many things, for computing, for accounting, for stockpiling, for engineering, for application, for telecommunication, for banking, whatever. Can you imagine? The memory is responsible everything going in and out of the memory. So it has blocks of cells that designate assignment or task irrespective of the unit or what is to be done. Now each has a unique address. Can only store limited amount of data. The memory can only store limited amount of data. Okay, based on the capacity of the memory. Every memory has some bytes, gigabyte or megabyte, depending on the capacity of the memory. So it divides the task based on its capacity and carry out this functionality based on this capacity. Now, can only store limited amount of data. Memory can only store limited amount of based on its capacity. Now, for example, we have bytes. Byte stores 1 character of a data, and we have word. After word, the smallest one is the bit, B-I-T. Okay, bit, B-I-T. Bit is for pop of a data, right? Word is selected letters of a data, and byte could be sentence of a data. Okay, so all of these are being done by memory. Now we move on to the next one. These are the blocks or cells in a memory. So there are some cells responsible for arithmetic and logical units. There are some cells responsible for iterations. There are some cells responsible for computation. There are some cells for whatever. Now let's move on quickly. Memory, still on it. Each memory cell is a set of circuits. If you go to, like the Intel will show you, the processor, you can see that is an integrated circuit. Microchips. Using semiconductor, if you're from physics, you understand this very vividly. Or electrical engineering, you understand this very vividly. Integrated circuits made from transistors that are used to carry out storage. Okay. Now each circuit is on or off, represented by 1s and 0. If you've done digital system, 1s and 0. 1 is for on, 0 is for off. Each circuit corresponds to a bit. That's the binary digit, just a digit. Okay, a bit. Most computers use 8 bits. circuits to represent a character. And a character is a byte. 8 bits equal to 1 byte. Okay. 2 common bits coding scheme that are used in memory. Coding memory is the ASCII, the American Standard Coding something. And then the EBC, DIC coding techniques. These are the 2 techniques that are used for coding memory. The ASCII and the EBC, DIC. Now we move on to the next one. The 4th one is the arithmetic and the logical unit. Okay, they go together. Arithmetic and logical unit. Here, decisions are made, mathematics operations are carried out. Now, what this one does is to carry out mathematical operations like additions, subtractions, multiplication, divisions are done here. And another task that is being done in the arithmetic and logical unit is the logical operations or comparisons of numbers. Okay, is done in this aspect. Now, and let's take a look at the compositions of the arithmetic and logical unit. This consists of the VLCI circuits on the silicon chips. Okay, now all of these are chips, silicon chips. They are made with silicon, semiconductors, right? So memories or processors are made with silicons. Okay, chips. They are made on silicon chips. Okay, integrated circuits on silicon chips, and can perform up to billions of operations per second. Can performs up to billions of operations per second. Yes, billions of operations per second. In 1 second, the ALU, arithmetic and logical unit, is able to perform billions of operations. In 1 second, numbers are taken from memories as inputs and results are stored in memory. So the ALU takes numbers from the memory. Remember, it's a segment on its own in the CPU. Takes number from the memory, process it. After doing the iterations and the computation, then it saves the result in the same memory. Is that okay? It sends it to memory. Remember, it's in its own CPU. Okay? The ALU is in CPU. It's an integral part of CPU. Is that okay? Now, we go to computer files. We go to the 5th one, the files. Right? We go to the 5th one, the computer file. It's called the files. Now, file devices used to store vast quantities of data. We use the file devices to store very large quantities of data. Okay, of data. Main memory is limited. Because the computer main memory is limited, cannot save every task you have, operational task you have. So we look for files devices to store. Could be disk, could be hard drive, CD, DVD, whatever, floppy disk, external hard disk, whatever, that are used to copy files. They are called file devices. Okay, computer files. They are called file devices. Why do we need this? Because the computer main memory capacity is limited. So if you're doing a lot of volumes, or you do volumes of work, the computer itself will in few years will be like, you will not have capacities to save. So you bring your external devices to carry out this. Now let's take a look at the advantages. File devices, or what we call the secondary memories, they are called secondary memories, secondary storage devices. Okay, they are called secondary memories. Now they're used to store additional data that is non-volatile. Any data that is not volatile is saved there. Now like RAM. Okay. Now we go to the disadvantage of this type of file devices, external devices, the hard drive, the floppy, the pen drive, whatever you want to call it, the disc, the DVD, call it anything. Okay. So any of these, which we call the file devices, has advantages that we mentioned for storage, huge storage of non-volatile document or files. But the disadvantage that it has relatively slow speed. It's not so fast. It's not so fast. Speed is an issue in this regard. Now let's talk about the storage devices. We've talked about the file devices. Let's talk about the storage devices, which includes what we've mentioned. Storage devices include the magnetic tape drive, the disk drive, the floppy disk drive, the whatever drive you can think of. Okay. Then also inclusive of that is the optical CDs and the DVD drives. Is that okay? Now, Let's move on, still on the types of computer files. On the types of computer files, we have what we call the sequential access files, and we have what we call the direct access files. Now, sequential access files, what it does is that records are stored in sequence. From the name sequential, the records are in sequence according to files control key from the control unit of the CPU. Okay? Files are stored in what? In sequence. In sequence according to the files control key from the control unit of the CPU, and usually stored on magnetic tape. The sequential access files are stored on magnetic tape. Now let's go to the second types of computer files. The second one is called the direct access files. Now, direct access files, what it does is that records can be accessed immediately without regards to physical location, without any regard to physical location. Now, stored on direct access storage devices. Okay, stored on where? Direct access storage devices. We're going to look at these direct access storage devices now. Now, let's take a look at types of direct access storage devices. Number one is the fixed, or what you call the hard drives. The hard drive. Okay, that's number one of DASD. Number two is the optical disk storage, like your CD-ROM, CDRW, that's CD writing. And then you have your DVD-ROM, your DVD-R, your DVD-RW. All of these are called the optical disk storage. The third one, the third type, there are three types of DASD, direct access storage device. Three types of it. The first one is the hard drive. Second one is the optical disk storage. The third one is the removable drive. Now, the removable drive, the one you call the pen drive. You know, pen drive is a removable drive easily. So the pen drive, the floppy drive, the zip drive, the flash drive, the keychain drive, whatever you want to call it, then all of these fall in the removable drives. Now we go to the last but not the least of the 6 block segment of a whole computer unit. The last one is called the control unit. The control, as the name implies, what it does, it controls what is taking place, everything that is taking place in the computer. Like, it takes data from the memory, gives to ALU, the arithmetic and logical unit, to process, and also send it to wherever you want to send it. It saves it temporarily in the memory, sends it to wherever he wants to send it. When you make a request, he does all the tasks, the control tasks, the logical tasks, and so on and so forth. Now, it controls the other 5. You see, as the name implies, it controls the other 5 components of the computer we talked about. Okay, and it's used to take advantage of speed and capacity of other components. So it calculates, you understand their speed and their capacity. Every other component that we mentioned, the CU, which is the control unit, is able to take advantage of their speed, so it knows which channel to use to send, and so on and so forth. List of operation is responsible for the list of operation called the program of your computer. All the operational programs of the computer, the control unit controls them. It tells the control unit what to do, right? Now, these operations are read from memory. They are read from memory. They are interpreted and carried out one at a time, and stored program concept, right? Stored program concept. They read one at a time, and all is done by the control unit. Now, stored program concept. Let's take a look at the stored program concept that we just mentioned. Computer program. Let's talk about computer program. Okay. A computer program is just a list of what is to be done for an application. And it's not only that, it also tells each step of the operation, or the operation which is called the instruction. It tells the steps of the operation that you call the instructions. So a computer program gives the list of what is to be done for the application and gives us the step-by-step operation called the instruction. That's one. Another one for the computer programs is the machine language. The machine language were some of the things we earlier developed during the evolutions of the computer system. Now, the computer program written for specific computer model. Every computer model has its unique program at that time, right? Now, program executed by control unit. Yes, the control unit, remember, it's the heartbeat. Okay, so programs are executed by the control unit. Consists of operation codes and addresses. It's operation code, which operation, where is it, in the address, the MAC address, and every address of that operation and where it's stored, right? It's responsible for that. Another thing we looked at in the stored program concept, apart from computer program and machine language, is the measure of computer power. The measure of computer power. Now here, millions of instructions per second are carried out. Millions of instructions by CU. Okay? And millions of floating points operation per second are carried out. And then another thing we're looking at in the stored program concept is the benchmarking. We say benchmarking is used to compare the speed for running a set of jobs on different machines. Okay? So meaning you benchmark the operation of this with the operation of another machines. So it's always done for every computer. Now let's move on to the types of computer system from the evolutionary time till date. Remember we start with what we call the microcomputers. What we have now is the microcomputers. So we started with the supercomputers, right? In the days of the 50s. We had the supercomputers. Now today we have the microcomputer. Computers are so cheap you can buy them $200 now to $400 to $4,000. Ranges from just $200 to $4,000. Can buy your computers, right? For today's computer, the microcomputer, which are the one you have now, the desktop and the laptops and the notebook you have now, they are your microcomputers, right? Okay, so there are MF lobs, which is our MF lobs, which is the millions of floating point operation per second. That's the MF lobs. Okay, their MF lobs is from 500 to 5,000, the capacity of what they can do. Then the primary uses the personal computers today. They are for personal computing, whatever you want to do. You want to type an email, you want to write a document, prepare, use. We're talking about the software that are used with computer students. The clients in server application, web, their clients, and whatever, small business processes, whatever you want to do with the computer, these are done within this concept. These are the computers we have in today's world. Then, before today's world, we had what we call the mid-range system. That one was the third generation. And then what we have now is the fourth generation, right? Fourth or fifth generation computers. Now, before, the mid-range was like the third or fourth generation computer. Then it used to be very expensive, in the 80s. In the 80s, we had the mid-range computers, whose price were ranging from $4,000 to $1 million. Can you imagine that? The MF lobs was $2,500 to $250,000. They were so a lot because these were big computers. They were departmental computing specific applications. Okay, they were very huge in big organizations. Individuals usually do not have these computers during this time. Although they were mid-sized and they're used for business. Now, before this mid-range, we had what we call the mainframe computers. The mainframe computers were super expensive. You know how much to buy then? You need $500,000 to buy a mainframe computer, to $20 million to buy a mainframe computer. Can you imagine that? They were for large business computing processes. Individuals were not having this type of computer. You cannot even afford it. Then, the first generation were called the supercomputers. They were very huge. You need $1 million to $100 million. Can you imagine that? Numerically intensive scientific calculations, very large web servers. That's what they were. Okay. Now we move on quickly. Types of computer system. Right? We've summarized them. Right. The microcomputers, the one we have for our personal computing, for can generally be carried or moved about by person from one place to another, or your daily work. You have a keyboard and a display unit. One keyboard, one display unit in this type of computer. It's a one compartment. Okay, it's not a large size. A good example is your desktop PC, your laptop, your notebook, handheld or personal digital assistant, your PDA, your tablet PC. All of this belongs to the microcomputers. Okay, good example is the picture you see right here. But remember, this were a bit in the early 2000s. Now we have finer computers. Okay, don't be despaired. These were Dell or HP at that time. You know, HP, Hewlett Packard. HP is a short form of Hewlett Packard. It's an American company. Okay, they used to be called Compaq, and then the name HP, Hewlett Packard. Okay, so these were the computers then, the way they look at that time. But now they're finer. We're still doing microcomputers, but they're finer than this. Now we move on to still on microcomputer. Two major microcomputer platforms. IBM is also a US company. Okay, that are also into computer manufacturing. IBM compatible PC, personal computers. Apple is also a US company. Microcomputers. Okay, but they don't use Windows. Apple don't use Windows. They have their OS. They don't use Windows OS. They use their OS. Now, I have been put to a mirage of uses. These computers are used for what? Record keeping, word processing, like Word document, presentation like PowerPoint, programming like Access database programming, and a cleared and inklet server system. Programming is not only database is not only Access. You can use the SQL for carrying out database management system. Okay, now we move to the second, the third generation, because the one we just described is the fourth generation. The third generation, we are in the 1980s. There are two types of computers then. We have the workstation and the mini computers. The mini computer is not, when you hear the word mini, it's not the laptop you have today. Mini computers could be like the size of your table. Okay, they were called mini because the workstations were very huge. They were big, like big typewriters. They were very huge. Okay, these were the computers we had at that time. Okay, let's move on quickly. Now we move to the still on mid-range today's mid-range. Servers, today they're mainly used for server application. Server for clients and server application, web server, and so on and so forth. They have low-end, essentially high-powered PCs, typically built on Intel Pentium, Celerons, and Xeons, and AMD processors is what they use. Okay, not the i7 and all of this thing we have for our personal computers today. They often run on Windows Server software, yes, and then the high end of this type of mini computers or mid-range computers were powered by IRSC processors or top-of-the-line Intel and AMD processors, usually run Linux or some variation of Unix. Okay, now we go to the second generation computer, the mainframe, right? The mainframes were a computer platform for most major corporations and government agencies, like the big corporations like ExxonMobil, any major corporation you can think of, the first, what you call the Fortune companies, first 500 Fortune companies, or today we can say first 1,000 Fortune companies. They were the one that had this type of computers, and then big government agencies like the FBI, like any big government agency, they had all these type of computers. Okay, major strength is versatility in the application processes. They were very versatile in processing of data. They were huge and capable. They have capability in processing, and they were used both in the online and the batch processing, integrated enterprise system, engineering and scientific applications, network control, system development environment, and web servers. They can do all of these, okay, iterations. And the major players today for this type of mainframe is the IBM, Fujitsu. You know, Fujitsu, I think Fujitsu is from Japan, IBM is from United States, and Unisys is also from United States. Now, the supercomputers Our number crunchers at 250k MF flops, right? The supercomputers were super huge, unbelievably huge, handles problems generated by research scientists. So they were mainly used for research that time. High-end supercomputers located in government office and research and development labs. This is where you used to find them. Individual that could not handle it, can't have it. It's not easy. And the top universities in the world, like Harvard University and these top universities in the world, could at least afford it. They were very expensive, up to $100 million. The cheapest or the lowest in capacity and speed were sold for $1 million US. So you can imagine. So how a small business will have this? Cannot that time. So it was one of the fastest supercomputers. The IBM Blue Gene was one of the fastest at that time. Now let's move on quickly. We've looked at the hardware. Now it's time to move to the software, the second segment, right? Now the software is divided into two: the application software and the support software. Now the application software is divided into, you can simply call it the operating system, right? It's divided into the language translator, the database management system, the case. Case is the computer something for engineering, software engineering. The communication interface program, utility programs, all these are the application software. And then you have the support software, right? Now let's take a look at them one by one. The application software. Programs written to accomplish particular business tasks. For example, if you write a code or a program for accounting, is an application software. A program for paying salary, payroll, is an application software. A program for inventory, taking inventory of your stock, is an application software. Sales invoicing is an application software. Programs that users interact with, their application software. Anything you interact with, you use. Whenever you're using a computer, you're always busy using them, like the access, the presentation, the word processing, and all of this. They are all application software. Software for standard application typically purchased from a vendor. We usually buy it from a vendor. One of the vendor is Microsoft. One of the vendor is what? Microsoft. So we normally purchase this application software from a vendor or a manufacturer. Is that okay? Now, software for applications are unique to the organization, typically developed internally. You know, if you have a very high level, if your company is very big, you can use your IT or software engineers or your programmers to develop your own application software that you want to use for your program. Like banking, you can make your software for your banking system. Like our online university, we can make our software for our online university system. So you can develop your own application software. All the software that you interact with, you use, are called application software. Is that okay? Now let's move on quickly. Accounting software package, therefore commercial accounting package for small business, like for your ledger, general ledger, account receivable, account payable, inventory, payroll, time billing, job costing, fixed asset accounting. All these analysis that you carry out and reporting, that tools that you carry out, that you develop, they are all application software. Is that okay? Today you can buy them as cheap as $500, even less than this today. You can buy a software package for a cheaper amount. Okay, because they are so in everywhere. Now, so many people are programmers, so many people are making software. We now have apps and so on and so forth. They are all application software. Now, let's talk about personal productivity software. May be used as a software suite. A good example of productivity software is the word processing, what you call the Word document, spreadsheet, what we call the Excel, the database management system used by Microsoft Access. You can use Microsoft Access, even though it's not the only one. You can use SQL to do this, to do database, but you can use Microsoft Access also to do this. And then presentations, graphics. This one you use what we call the PowerPoints, electronic mail and groupware. Okay, all these are what we call productivity software. They enable you to be productive, to do your task in your office all this software. So you should be good in all of this: word processing as a student, spreadsheet, which is your Excel. You should be very good with Excel, calculation. Excel, with Excel you can plot graph, you can do calculation, you can do analysis, you can do so many things. You can do mathematical calculations, you can do data, and so on and so forth. Then you have the learn access for database. You can create a company database. Okay. Then presentation graphics like the PowerPoint presentation with Microsoft PowerPoint, and electronic mail and groupware. So all of this, we have this, then you're good to work in an office. If you're very good with this, you can work in any office, in any organization. You only need to be trained a little bit or show what to do. Now, personal productivity software. So do not graduate from university without mastering any of this. You have to master all of this, not any of this, all of this. You have to master very well all of this before you leave the four walls of the university and go to the working environment, what you call the labor market. Now, let's take a look at the personal productivity software, the database management system. They used to create what? They used to create, manage, and protect organizational data. You create all the organizational data, number of students, for example, school management system. You use the database management to create the whole school database, the names of students, their age, their class, their parents, where they come from, class they are. You create class by class, all this data, classes, timetable, whatever. All of this, you use the database management system to create all of this. The most popular is the relational database model. It's the most popular one. You can use Microsoft Access to create this. Okay. Now, the database itself, it's a shared collections of logically related data organized to meet organizational needs. Okay. A good example, you can use the Microsoft Access to do this. Still on productivity software, the presentation graphics. They are used to create slides for business presentation, for educational presentations, for defending your thesis. You have to make your PowerPoint. For any presentation for conference, you have to make your PowerPoint. Business, your offices, to present what you're doing, you have to make PowerPoint. So they used to create slides for business presentations and educational presentation. All allows embeddings of clips, arts, photos, graphics, and other media, video, whatever media you need. So here a good example is the MS Office, which we call the PowerPoint. Now we move on to, still on the productivity software, the electronic mail. We have the electronic email, so you should know how to use the email, okay? And then the groupware, the one maybe from the company, incorporates emails and other productive features such as calendaring, scheduling, and document sharing. If you know how to do this, use software to schedule programs, calendars, and all of this is also another big advantage to work in an office organization. A good example of what you use MS Office is the Outlook. You use the Microsoft Outlook. Many of us, we ignore this. You use the Microsoft Outlook. You can create a calendar, schedule events, document sharing, and so on and so forth. Okay, now we move to the browsers, what we call the WW browsers, World Wide Web. WW is World Wide Web. Talking about the World Wide Web browsers, they used to access information, right? To navigate, to access, to mitigate, to move around, to meander, right? On the web, on the internet. That's what they use for, World Wide Web. Okay, they can access the internet. Okay. They are hypertext based approach. Okay. Now, here we have what we call the pull technology. Browser requests a web page before it is sent to the client. The browser itself will request a web page. That's what we call the pull technology, and then the web page will be sent to the client. Then the push technology, the data sent to the client without requesting it, such as emails, payments. This one is called the push technology. You didn't request for it, but you got it. It's called the push technology. The pull one is one you request and it's sent to you using the World Wide Web. Okay. Now, examples of web browsers are the Internet Explorer. The Internet Explorer today is owned by Microsoft. The Firefox. Firefox is owned by Mozilla. You have the Safari. Safari is owned by Apple. Okay. All these are companies in the United States. Is that okay? Okay, now we move on to now we're done with the application software. We're going to support, system support software. This one, they enable the application software to be carried out. Without the system software, the application software will not work. You know the bootstrap, when you start your computer, is initiating, bootstrap, and all of this. These are support software. Without the support software, the application software cannot be executed. Now, this one, they also ensure the support software ensures that computer hardware and software are used efficiently, and they can be purchased from a hardware or software vendors. Okay. Now, a good example is the operating system, OS. A good example of support software is the operating system. Operating system, remember, it was a course in your second year of wholesome University, right? Operating system. So operating system is an example of system software. Either you say system or you say support software. So the name can be used interchangeably. System software or support software. You can say system support software. You can combine it. System support software. Now let's take a look at the operating system. Usually purchased from a manufacturer, of course, of a computer hardware that OS will be used on. Because when you buy your hardware computer, it comes with it. Like the price is intertwined. It's already added to it. So as you're buying your computer, you already have this support software comes with it, because the Microsoft and the computer manufacturers already have this in place, like a deal already in place. Okay, so it's not like you buy a hardware, then you go and look for software to buy. No, it comes as a package together. It's already in the vendor. Okay, now here, complex programs that controls operations of computers hardware and coordinates other software. It coordinates other software. Every application software you go to use, the operating system, what you call the support software, system support software, is responsible for the coordination. Super responsible. Then it's also responsible for the performance objective, to ensure that you maximize your work, your throughput, what you call the throughput. Work is really highly maximized. Then also user communicates with operating system software for input, output, storage. All of this work, when you want to input, because you're dealing with the processors and the memory. Remember, all the processors and the memories, they are all operating systems. Okay. Now, easier to use with graphical user interface, because without the GIU, the graphical user interface, it will be difficult to even carry out a lot of things with the computer, like the command line interface. You know, the other course, network system, network security, cannot carry out without the GIU. Okay, operating system, this is the blockchain. You have the operators, you have the operating system here, we have the operating system here, and then we have these the operators. We have the processors, remember the processors, which we talked about, the communication controllers, the control units, and so on and so forth. These are the terminals, and so on and so forth. So it's a package, a total package that intertwined with the hardware and the operating system. They are intertwined. So they connected from the first start, from the very start, the processor, and so on and so forth. Everything is connected. So you're buying one package. Okay. Now let's take a look at some of the concepts. Job control language. The instructions used to communicate with the operating system. They call the job control. Certain instructions that are used to communicate with the operating system. Now we have what we call multi-programming. The multi-programming is employed on larger machines to overlap inputs and output operation with processing time, keeping the CPU busy, and not just keeping it busy, speeding up the executions of programs, right? Then another task here in the operating system is the multitasking. It carries out multitasking. Operating system does multitasking job, and this is very similar to what we described other multi-programming. Multitasking is similar to multi-programming. Now it also carries out what we call the multi-threading. Multi-threading is very similar to multitasking, but multiple threads within the same programs are overlapped. Then multiprocessing, another task it does is work that takes place when two or more CPUs are installed on the same computer. So here we measure job control language, one of the tasks of the operating system. Another one is multi-programming. It's able to carry out, employ larger machines to overlap both the input and output processing time and all of this. There are many things: processing time, logic unit, arithmetic, all of this from the CPU. He is able to carry out multi-programming. He's able to carry out multitasking, which is similar to multi-programming, but employed on the microcomputers. Then he's able to carry out multi-threading. Here, multiple threads within the same programs are overlapped. Then it's able to carry out multi-processing, the work that takes place when 2 or 3 computers are connected to the same, 2 or 3 CPUs are connected to the same computer system. Okay, still on it, we have what we call the virtual memory. The virtual memory optimizes management of main memory by switching in and out portions of programs from the DASD. Permits multi-programming to operate more efficiently in the computer system. Then let's take a look at the support software. Still, we have what we call the proprietary systems, and we have the OPU system, and we have the IT platform. Now, what is the proprietary system? Proprietary system includes the operating system written for particular computer hardware configurations. A good example in our today microcomputer is the MS-DOS. We have the Vista, we have the Windows 7, we have the Mac OS here. Okay, the MS-DOS, Microsoft DOS is an example of proprietary system, or an example of a proprietary system. We have the Vista. Vista came before the Windows 10, or Windows 8. After Windows 8 we have Vista before we came to Windows 10. Then we have Windows 7, we have Windows 10, Windows 11. Today we have up to Windows 11, right? Or Windows 16. Then we have the Mac OS. All these are for microcomputer. What are for large system? We have for large systems we have the IBM. IBM, they are today very keen in making very large computers beyond your imaginations. So the IBMs, they provide the operating system for large system, the Z operating system and the ZVM. Then let's go to the second one again. Second one in this regard, the OPU systems. OPU system, they're not tied to any particular computers. Like a good example of OPU system, Unix and Linux, or they are OPU system. They are not tied. MS, Windows, they are tied to almost every computer we use, and the Mac OS, they are tied to Apple computers. But the Unix and Linux, they are not tied. They are called OPU systems. There's OPU system because they are not tied to any computers. Anyone can just download and install in any of the computer, and is suitable with any of the computers. So this type of software that are not tied to particular computers, they are called the OPU systems. Now we go to the IT platform, set of hardwares, software, communications. OS names usually apply platforms. So IT platform is a set of hardware, software, and communication systems. Is that okay? Now let's go to server or network operating systems, NOS. Software running on a server that manages network resources, of course, because from the name you can tell that there are software that are running on servers that manages the network resources and controls the operations of the entire network in any given organization very efficiently and effectively. Now let's take a look at another job it does, the NOS. NOS means the network operating system. Another job it does is enhance operating system that allows for what? Sharing disk drives and printers. The server is very responsible for sharing disk drive, right? And sharing printers. There could be like 20 computers in an office sharing one printer. Also, another thing is handling server-side software and server applications. Now, major players include the Unix and Linux, and then Microsoft Windows servers. These are some major servers, the operators or vendors that are into this business. Now let's move on to the support software, the first and second generation languages. The first generation language is the machine language. This was the very first generation language that enabled the birth of computers. So when we developed the machine language, then computer came into limelight. Okay. Now each instructions must be expressed in a unique form for a particular computers. Okay. So they were not like every instructions was meant for a specific computer. They were not like unified instructions. So which makes it very difficult. Now, a complete program consists of thousands of instructions, and programming is a tedious, time-consuming process at this time of this during the time of machine language. Now, after that, in the second generation language, we develop what we call the assembly language. And in this, the assembly language easily remembered mnemonics. Mnemonics, short form of remembrance. Mnemonics operation code substituted for machine language operation codes. So mnemonics like the short forms codes for operation. So the assembly language was able to combine many different types of the basics, fortras of the machine language, that we used to have in the first generation. So assembly language was able to combine them. The assembler used to convert the mnemonics codes to machine language also. Okay, now first and second generation languages include all of this, right? Assembly language program, computer order control of assembler, machine language program. Today now we are doing advanced machine language or machine learning. We call it machine learning now, today's world, which we call the artificial intelligence. Okay, the AI today, machine learning, all the AI you're learning, they are machine learning also. Okay, so we have advanced to another level of computer programs, programming robot, programming. We used to program hardware robot, now we're programming software robot like ChatGPT. They are all software machine robots. Now let's move on to support software. Third generation languages came up after the assembly language. We developed the third generation machine language. Procedural languages like the third generation evolved. Okay, they evolved. Now they were used to express a step-by-step procedure devised by a programmer, typically machine independent, easy for programmers to learn. Structured program, they were very structured, easy to learn, divided into modules. You learn module 1, go to module 2. They were given tasks, assignment, every module. So it was easy, it became like a structured education, okay, not confusing like in the first and second generational case, so on and so forth. So now let's move on quickly. Here includes the compiling and running a 3-generation program. Here you have the procedural language program, the computer order control, then you have the machine language learning. These are the blocks. Load the machine language program, then computer execute the language, and then the data is keying in, then you get your report. So these are the stage by stage for the 9 stages of the program development. The problem, first you identify the problem, you develop the algorithm to do that, then you carry a conversion of algorithm to computer understandable logic, and then you move to program preparation. You key in the program into your computer, then you compile the program, then you execute the program, and then you debug the process, and then you use the program to carry out your actual data experimentation. That's that. Now, still on the third generation languages, most popular procedural language and decade were introduced. A good example, in the 1950s, we had the Fortran. In the 1960s, we developed the COBOL. COBOL is the Common Business Oriented Language, or what you call the BASIC. And then in the 70s, we developed the C language, from C to C++, C++ to C++. Today, so it's C++. So these are the languages. Now we move to the 4th generation language. After the 3rd generation procedural language, the 3rd generation is a procedural language, and then we went on to the 4th generation language, which is called the non-procedural languages. Non-procedural. Okay, now easy to program but less efficient for computers to run. Use more of English-like statement for programs instructions. Today may be referred to as the language for business intelligence. Right? Examples include SAS, IBM Cognos, SAP Business Object, Oracle BI Enterprise Editing Plus, Microsoft SQL 2008 Services Analysis Reporting. Okay, so these are some of the good examples of the language. They are called non-procedural language of the 4th generations. Now let's take a look at the markup languages. After the fourth generation, we now have what we call the markup language, the ones that are evoked today that you need to learn if you want to be a programmer. One is the HTML. Okay, HTML is very important. With it, you can develop a website. With it, you can do so many things. You can code, you can do basic coding, and so on and so forth. So these are languages that have evolved. They're called the markup languages. They even evolve out of the fourth generation language, which is non-procedural. What do you use the HTML to do? It includes to create a web page. Yes, like I already mentioned, to create a website, web pages. Consists of special tags that tells the web browser how to display various elements on the web page. Is it boldface, italicized, or whatever. Another markup language that has evolved apart from the HTML is the XML. The XML is used to facilitate data interchange among web applications and web services. So data interchange among web applications. You know, there are different web applications. So to change data from one web application to another web application, we need the XML. We need the XML. Okay. They are meta language consisting of tags that identify particular data elements. Okay. Now let's take a look at an example of these XML languages that are used to interchange different application program on the web. Now, if you type something like this, you program code, you say game type, you say equal to quotation college football, close the inverted quotation, date, you put the date, you close it. This is a very good example of XML language that are used for program interchange on the web. Is that okay? So all of these are sequential examples of XML language that are used on the web. Now let's go to still on support markup languages. Then we came to what we call the object-oriented programming, OOP languages. Neither the third generation or the fourth generation, this is a new paradigm, a new shift. It's a object-oriented programming was a shift away from the third generation language and the fourth generation. Remember, the third generation was a procedural language and the fourth generation was a non-procedural language. Now, this object-oriented programming was a shift away from these two. Now here, we create objects once, we store them, then we reuse them. That's it. You just create the object once, you store, you reuse every time. You don't have to create every time. Once it's created once, you can use multiple number of times. Okay, that's why it's called object-oriented language or object-oriented programming. Now, object example includes your text box is an object, is considered an object in this language coding, and your checkbox is considered an object. Now, most common languages include other this object-oriented programming include your what? Your C++. So, if you want to be a software engineer, a programmer, you need to learn the C++. Then another one is the Java programming. They all fall in object-oriented programming. So, if you want to be a good computer scientist, you need to learn how to do this programming. Another one is the Visual Basic. The Visual Basics.net and C#. So you can learn at least two of these or all of them if you're capable. And you'll be plus your HTML and XML, you'll be a super web guy and a super programmer. So these are examples of object-oriented programming. This is a JavaScript. JavaScript. Okay, you can use the JavaScript to also write a website. Languages for developing web applications. HTML is the most common form of user interface that is used for developing web application. Server-side programming language include the server one includes the PHP language, the Java servlets, and the Java server pages. All these are the server programming languages. Then from the Microsoft, they have one called the Microsoft Active Server Pages, ASP.NET, usually the very popular one, ASP.NET from Microsoft. The Adobe's Code Fusion, also is another one, okay, for Java programming. Now let's go to database management system. Which one do we commonly use for database management system? System that creates a database management system helps to create, store, and manage modifications to data in a database and make data accessible for query and for reporting. So we need to learn this: data for query and data for reporting. And we can use what? Microsoft Access can be used for this. Data dictionary and data directory is another one. And here we have what we call the repository for data definitions used by database, any database system. Like university, they have repository where they store so many things. Now, well, we have what we call the data warehouse, a very large database or a collection of databases for decision support that use a database management system optimized for analytic and data mining. Okay. Now let's go to still on database, database management system architecture. We have the hierarchical, we have the network, we have the relational, we have, okay. So the first one is hierarchical. Like the data are arranged in a top-down chart in an organization, top to bottom, kind of. Example is the IBM information management system. The second one is the network. The data are arranged like the way a city, highway, the way we plan a city, you have a highway system, and then you have several paths on either sides. Okay, you have paths from one piece of the data to another. So like a highway system, you have piece of data. So this type of arrangement of database is called the network. The third one, which is the most famous and most commonly used database, is the relational. This one we usually create Microsoft Access. Relational database, most common type, and data arranged in simple tables, records related by storing common data in each table or each data. Okay, example is Microsoft Access, okay, and SQL Server, Paradox, so on and so forth. Now, still number 4 is the object oriented. The number 4 for the database management system is object oriented. Here, the data can be graphed, video, and sound, as well as simpler types of data. So, when you hear the word object, you already know we are talking about graphics, video, and so on and so forth. Attributes and methods are encapsulated in object classes, and relationships between classes can be shown by nesting one class within another. Nest of class, cascading. Is that okay? Example is the Verset object database, Progress object stores, and Objectivity DB. Now the fifth one is the object relational. We have the object oriented, we have object relational. This one is kind of a hybrid. Hybrid approach that can handle the complex data type with the simplicity of the relational model we described in number 3. Number 3. So we've described the relational database, just creating tables, right? And keeping all the data in tabular form. So in object relational, it's just a hybrid of the object-oriented database with the relational database. Okay? A good example is the Oracle, IBM, and DB2, Cloudscape, and FFE software, SQL, and so on and so forth. So now let's take a look at query language example. The query language. Query language is the language for database. Query and reporting is the key segmentation of a database system, right? Now let's take a look at select order. You first have select order, customer hashtag, customer name, and so on and so forth. Okay, these are orders of queries that are written in this type of database. Now let's take a look at the computer-aided software engineering case. Yes, case. Computer-aided software engineering. Computer-aided software. This one is used for for manufacturing, computer design, computer-aided software, and so on. It's a tool, and this tool is a collection of software tools to help optimize all phases of the software development life cycles to increase productivities of software designers and programmers. Now, case 2, that's computer-aided software engineering tools for OO development for unified modeling. Now, one of it is the UML language. UML language equals to the general purpose notational language that is used for specifying and visualizing the complex software whenever the need for it arises. Now let's take a look at the communication interface software. Communication interface software, they are used for large computers. They are used for what? Large computers. Because they call communication interface software. These are used by telecommunication companies and big computer organizations and government agencies. They control communication between workstations and terminals connected to a network and also central computers, right? Now let's talk about the web servers. We say the web server software serves the web pages to the web browsers. What are file transfer protocols? These are some protocols that are run on the system on the web. They transfer files from one computer to another. What of utility program? They use to link together programs and sub-programs to merge files and to check for viruses and so on and so forth. They are called utility. They can do so many things for you. Now, key software trends. Now, software trend is one of the things we're looking out for is concern for human efficiency. Okay, one of the trend why we keep evolving and developing more software is to be more efficient, for human being to be more efficient. Another reason is purchase application software. Okay, one reason why software keep trendy is we are having huge requests for application software. So there's demand, if you want to talk from the economic perspective. Huge demand from application software. So it has to trend. If there's demand, there must be supply. It has to be. And there's also more open source support software. Yes. Nowadays we have open source support software. We have so many on the web you can download and use for your management system in your organization. Okay? They are called the open source. But they're a little bit risky, virus and whatever. Okay? But they're free, you can use. Now, more programming using object-oriented languages. Okay, we're having more programming because we have more people study computer science and they're using object-oriented languages. So we are getting more. So it will definitely trend, software will trend, because we have more young people programming different things. So the software will definitely trend in this era. So we have more emphasis on application that runs on intranet and internet. Remember, intranet is within your organization. The internet you use within your organization. And internet is the public one. This one is like private, this is public. So there's more emphasis on application on intranet and internet. So because of that, software will definitely trend. Then another reason why software keep trendy nowadays is the user development. Okay? User development, more user development. So it will trend. If there are more development of software, then software will keep trending. And there's more demand for it, then it will keep trending. More use of personal productivity software or microcomputers. More use of personal productivity software like the word processing, like the email, groupware, like the Excel, what you call the spreadsheet. All these are personal productivity software. So more user for it, then there will be more development in this regard. Now let's take a look at the hardware firms. The hardware firms, they kept expanding and growing because there is bigger need and bigger market for hardware computers. Now, what are the major players? Let's look at the companies, hardware manufacturer from the United States. IBM is one of them. IBM. We have the Hewlett-Packard. Hewlett-Packard is what we call the HP. You know, with HP computers. Okay, is a United States companies that are manufacturing computers. You know, when I say computers, we are talking about the hardware now. Okay, then we have the Dell. The Dell is also a US company. The Dell is a US company. We have the Apple. Apple Computers is also a US company. Now let's take a look at non-US company, non-United States company. We have the Acer. Acer is in Asia here. If it's non-US, it's Asia. So I think United States and Asia, in terms of computer technology, they are the leading people in this globe, on this global side of the world. We have Lenovo as a non-US company. We have Toshiba by Japan as a non-US company. Lenovo also, I think, by Japan. We have Fujitsu by Japan. We have Sony by Japan. I think Acer, I'm not sure Acer is Japan or China. So we have Acer either China or Korea. Maybe Acer is not Japan. Maybe Korea, South Korea. Lenovo used to be owned by the West, but they sold it. I think it's owned by either Japan now or so. Toshiba definitely is Japan. Fujitsu is Japan. Sony is Japan. Okay, they manufacture computers. There are more, okay, there are definitely more. Samsung is there, remember, from Korea. Samsung is there. Okay, but these are the non-United States. United States is IBM, HP, Dell, Apple, and so on and so forth. Now let's go to software firms. Software, like firms or companies that are manufacturing or designing or developing software. One is IBM, which is a US firm. They bought the Cognos SAP. The Cognos is the software for business-oriented programming. Then we have the Oracle. Oracle is a software owned by United States. It's a United States company. They bought the PeopleSoft and Salesforce.com. Oracle also bought Sun, the hardware and Java. So this IBM Cognos, which is a software, and Oracle, they are all United States. So that here we don't have a non-United States software company. Okay, Apple is using its own software, which is also a United States company. So I think in terms of software, United States dominates everyone. Hardware is between United States and Japan. United States and Japan is in the hardware of computer technology. The software is China. Okay, China also, yes, China also has it has become a big player, even though the names are not here because this was prepared some years ago. Okay, so China has joined the big, they are shakers and movers of today's world. So China, Japan, Korea, in the Asia world, they are the superpower of Asia. Japan, China, Korea, and we also have this part of China. What do you call this? Small China. It's a country on its own now. It's part of the Asia Tiger. Okay, if I remember the name, I will mention it. Okay, they are about 4 or 5 strong Asia countries which are into computer technology. Then, beside Asia is the United States. Is that okay? Now let's move on. I think with this we come to the end of our today's class. Thank you for joining us.